Using the concept of equivalent, we can say that K equivalent will be K1 plus K2 by 2. Then is a derivation of Newton's law of cooling. Suppose a body is at a temperature T and surrounding it at T naught. So the body will absorb heat at the rate this and it will release heat at a rate this. So the net power radiated comes out to be this. Now net power radiated can be written as dH by dt. So dH will be minus ms into dt. dt is change in temperature. So we equate the expression, we have this thing. So we have the differential equation like this. Now we take T naught 4 as common. So we get dt by dt is minus sigma here, T naught 4, T by T4 minus 1. Finally, we get this expression. Now we write T is equals to T naught plus delta T. So from here we get dt by dt is minus sigma this thing. And T is T naught plus delta T raised to power 4 minus 1. So this can be simplified to 1 plus delta T by T naught power 4 minus 1. Using binomial, we can expand it like 1 plus nx. So that will be 1 plus 4 delta T by T naught minus 1. We subtract it out and finally we get this thing. Now we get this as minus k delta T. This is the Newton's law that rate of cooling is proportional to the temperature difference. So this term can go over here. Now we write delta T is T minus T naught. Then we integrate the above expression from T1 to T2 and 0 to T. And after final calculations, this is the result that we have, that T2 as a function of time is this thing. If we analyze the graph, that will be exponentially decreasing curve like this. So initially temperature will be T1 and after a long time the temperature will become equal to the temperature of the room, which is T naught. So this is we can analyze. Now we can say that power is proportional to T4 minus T naught 4. So if the temperature of the body changes, so we can compare the two powers as P2 by P1 is T24 minus T naught 4 by T14 minus T naught 4. Here T should be in Kelvin. If it is in centigrade, add 273.15 to as to convert that into Kelvin. Next, we have a discussion on modes of heat transfer. So there are three modes: conduction, convection, radiation. So conduction is where material medium is needed, convection in material medium as well as gravity, and radiation is in the form of EM radiations, which is the fastest mode. There we have Fourier's law, which is about heat transfer through a conducting rod, which is maintained at certain temperature difference. Then we have coefficient of thermal conductivity, various concepts related to thermal resistances, various cases related to them. And finally, we have graphical variation of temperature as a function of the x coordinate, then temperature of the interface, and various cases related to that. Then we have another discussion on change of state, so which is either melting or boiling. So melting is concerned with solid liquid and boiling is concerned with liquid to gas. So there are certain